You know that feeling when you're talking about something and then suddenly an ad for it pops up on your phone? Or how Netflix just knows what movie you're in the mood for, almost better than you do? Well, it's not magic and it's not a conspiracy. It's machine learning, and we're about to pull back the curtain on how it really works.
I mean, really think about that for a second. You finish your show, and boom, there it is, a recommendation that is just spot on. How does that happen? Or your Spotify playlist that just seems to read your mind. What's going on there?
The answer to all of this is machine learning. And look, despite what you might see in the movies, it's less about computers that think for themselves and way more about them being expert pattern spotters. It's all about teaching a computer to sift through a whole mess of data, find the hidden connections, and then use those connections to make a really, really smart guess.
Okay, so machine learning isn't just one big thing. It's actually way easier to think of it as having two different personalities. You've got the student on one side and the detective on the other. And once you get how these two work, you've pretty much got the fundamentals down.
So these two personalities are called supervised and unsupervised learning. Think about it like this. Supervised learning is the student. It's like you're giving it a big stack of flashcards with the answers already on the back. It studies the examples and the answers, and it learns the rules. But unsupervised learning, that's the detective. It gets dropped into a scene with no instructions, just a bunch of clues. Its entire job is to look at all the evidence and piece the story together on its own.
So let's dive in with our student-first, supervised learning. This is the tool you grab when you know exactly what you're looking for and you've got a bunch of examples to teach it with.
So what is supervised learning, really? Well, it's a type of machine learning where the model learns from data that is already labeled with the right answer. For example, if you want to predict house prices, you'd feed the model tons of data about houses, square footage, number of bedrooms, and, most importantly, you'd also give it their final sale price. That price is the label. It's the answer key.
And the whole process is actually pretty straightforward. Step 1. You feed the model tons of that labeled data, house features and their matching prices. Step 2. The model gets to work, kind of like it's cramming for a test, finding all the hidden relationships between, say, having 3 bathrooms and a higher price tag. And then Step 3. The final exam. You show it a brand new house it's never seen before, and it has to predict the price. That's supervised learning in a nutshell.
But wait a second. How do we know if it's actually learning the material and not just memorizing the answers we already gave it? It's simple, really. We give it a pop quiz. And we do that with a really clever method called the train/test split. You take all your data, but you hold a chunk of it back, let's say 20%. You let the model train on the first 80%, and then you test it on that final 20% it's never seen. This is absolutely crucial because it stops the model from just memorizing the practice questions without actually understanding the subject. It proves it can handle new problems out in the real world.
Okay, so that's supervised learning, where we're the teacher with the answer key. But what happens when there is no answer key? What if you're just staring at a giant, chaotic pile of data and you need to make some sense of it? Well, that's when you call in the detective. This is unsupervised learning, and it's all about discovery. You literally just give the model a whole bunch of unlabeled data and say, go figure it out. No hints, no help. Its job is to be that digital detective, to sort through all the chaos and find the natural groups and patterns all by itself.
And this is where things get really cool, because the algorithm can make discoveries you aren't even looking for. Sure, it might group your customers by what they buy, but it can also find these weirdly specific, surprising connections. Data scientists call these latent variables. Maybe it finds a group of customers who only shop on rainy Tuesday mornings. It's a super powerful way to discover the hidden why behind what people do.
So now you've got these two powerful approaches in your toolkit, the student and the detective. How do you know which one to use? Well, it all comes down to one thing. What's the problem you're trying to solve?
Let's make it super clear. If you want to predict a specific outcome, like a house price, you need the student. That's supervised learning. But if you want to explore your data and find new segments, like grouping your customers in ways you never thought of, you unleash the detective. That's unsupervised learning. And for a classic job, like telling the difference between a cat and a dog in a photo, it's back to the student, who needs to be trained on thousands of labeled pictures first.
All right, enough theory. Let's get to the fun part. You've met the student and the detective. Now let's go on a little tour and see if you can spot them out in the wild, because trust me, they're everywhere.
When Netflix hits you with that because you watched recommendation, that is our student supervised learning hard at work. It's been trained on millions of people's viewing habits to predict what you'll want to watch next. You know that scarily accurate arrival time on your Uber app? Yep, that's a supervised model.
constantly predicting your ETA based on a flood of real-time data. Traffic, time of day, weather, you name it.
But then you hop over to Amazon and it says, customers who bought this also bought. That's our detective. That's unsupervised learning, grouping you together with a shopping tribe of people with similar tastes without needing to know anything personal about you. It's finding your people.
Your Discover Weekly playlist on Spotify? That's actually a tag team. It uses unsupervised learning to find your musical twins, other users with similar tastes, and then it uses supervised learning to predict which of their songs you're going to love too.
And then you have the really cutting-edge stuff, like Tesla's autopilot. This uses a super powerful type of supervised learning called a neural network. It's been trained on millions of miles of video to identify everything on the road in the split second.
And finally, of course, there's the TikTok For You page. This is basically machine learning on steroids. It's a recommendation engine that learns about you in real time. Every single swipe, every like, every second you pause on a video, that's all data that's training the model to get better and better at keeping you hooked. So you see, machine learning isn't just some crazy, futuristic tech for big companies. It's a new way of solving problems, of finding the signal in the noise. You now know the two fundamental approaches, the student and the detective. So the only question left is, what problem would you solve?